Hey folks, 8.1c. What is the probability of a simple random sample of 11, so n equals 11, salmon, and getting an average length longer than 23? Okay, I'm going to use the formula first. I'm going to use this formula. It's going to be very familiar because it looks just like the formula we used on the last test. And then the next video, I'm going to show you how to do this problem with your calculator. So be sure to watch both. So watch this once just so you have a good feel for what's going on. And then the next video, I will show you the magic of the calculator. Okay. So let's see. Here's our Z formula. So just like on the last test, let me just plug things in. The X bar, that would be the 23. The mu and the sigma always given. And the sample size is 11. Okay, now I might put the bottom in parentheses just so I don't mess it up. And let's see, where's this box? So 23 minus 20, all divided by 4 divided by root 11. So here's what I would do. Let's see, can you see that? Okay. On clear. 23 minus 20, enter, divided by parenthesis 4 divided by the square root of 11. Get outside the square root, put an end parenthesis, hit enter. 2.48746. So we have to round to the hundred, so 2.49. 2.49. So let's say you like doing it in one swoop. Make sure to put the whole numerator in parentheses, otherwise it won't work. So one more time, but I'll do it all in one swoop. I like breaking it apart. You see how I first did that? But if you do it in one swoop, so you do a parenthesis, 23 minus 20, end parenthesis, you have to put that whole numerator in parentheses, order of operations, divided by parenthesis 4 divided by the square root of 11, get out of there, end parenthesis. See how it's the whole numerator divided by the whole denominator? Enter. Same answer. Okay, great. So let me just move this over here, and we round it correctly. It was 2.487, so I'm going to put 2.49. 2.49. 2.49. Okay, so let's see what's happening. Average length of a salmon is 20, standard deviation of 4. We're sampling 11 salmon. That's kind of a lot. So what's the probability that the average length of those 11 salmon is going to be longer than 23 inches? If I talk to 11 salmon, the average length should be really close to 20, right? Because for every long one, there's probably a short one. So the average length is longer than 23. Probably a really low probability, and that'd be kind of weird. Would I just happen to be so lucky to grab like the 11 longest salmon in the world? So the probability, so we got our Z value. So once we have everything in Z, remember the center is 0. 2.49 is way out here, and longer than, so we shade to the right. And so right tail, I would look up opposite. I grab my Z table, so I would go to negative 2.49, and I would get, you can't even see that, 0064. So negative 2.49 right there, 0064. So this is 0.0064, which is less than 1%. So the probability of grabbing 11 salmon and their average length is longer than 23, that probability is less than 1%, 0.0064. Basically, I'm the luckiest person in the world, or something weird's going on, like this didn't really happen, or I cheated or something. So whenever you see a low probability, remember we said anything with probability less than 0.05 we call unusual or unlikely or weird. So this is a very weird event. sampling 11 salmon from this population and having the average of those 11 salmon be longer than 23? Super unlikely. Okay, so I'm going to redo this problem with the calculator. Okay.